Hey everyone, let's knock out example 8. Now we're going to be using a combination of ln and L'Hopital's rule, but we should know from the previous problem that the answer is going to be e to the negative fourth. Let's prove it. So for starters, if we plug in, maybe I should back up for a second and say, look, if we plug in infinity, right, if we just consider x values of bigger and bigger value, then we get the indeterminate form of 1 to the infinity, which might not look like an indeterminate form. It might look like 1. It might look like infinity. It's actually indeterminate. So what we're going to do is we're going to let y equal the limit as x approaches infinity of 1 minus 1 over x to the 4x, right? So ln of y equals the limit as x approaches infinity of ln of 1 minus 1 over x to the 4x. Right? Remember, we can put that ln inside the limit because it and the 1 minus 1 over x to the 4x functions are both continuous. Right? Now remember, as always, we keep writing the limit as x approaches infinity until we take the limit. Okay, now at this point, you might plug in infinity, right? Bigger and bigger values of x, and you see you get this. And that means, well, we can't use L'Hopital's rule yet, but maybe we can do that, right? And now we have a 0 over 0 situation. And so now we can use L'Hopital's rule to take the limit as x approaches infinity of 4 divided by 1 minus 1 over x times the derivative, which is going to be, actually I guess we don't even need the parentheses, it's times 1 over x squared, positive 1 over x squared, divided by negative 1 over x squared. So maybe you see that's where the negative sign is coming from, right? Because the 1 over x squareds cancel, but the negative does not. All right. So anyway, it might be nice to write this a little bit neater. We have negative 4 over 1 minus 1 over x. And then we can just take that limit and get negative 4. So y, which equals the limit as x approaches infinity, of 1 minus 1 over x to the 4x equals e to the negative 4.